I'm just waiting for Mr. Mukund Vasudevan to join us, and then we will start. And so while we wait for him to join, I think I'll just start with the introduction to the whole theme and the series that we are doing. So good afternoon, everyone. Welcome to the webinar on Catch the Rain, 3 R's of water conservation, reduce, reuse, and recycle. I'm Rita Roy Chaudhary, Assistant Secretary General, FICCI. This is a webinar by FICCI and the National Water Mission as a part of a series that we have been organizing. Many of you have been part of the earlier 2 webinars that we have done. The first one was on the 8th of July on the topic of rainwater harvesting, infrastructure preparedness and awareness generation. The second one was held on the 15th of July on the topic of groundwater recharge and aquifer management. And today is the third one in the series, which is focused on 3 R's. In all these webinars, we've had some very key messages that have come across from the panelists and from the discussions, that the importance of looking at water conservation, both from the demand side and the supply side, is extremely important. There is no one size that fits all. Different kinds of solutions would be needed. We need many more water champions and ambassadors to spread the message and to take the torch forward in helping to create the awareness around catching the rain. And that data, information, and knowledge sharing will be extremely crucial in this whole journey as different stakeholders take up initiatives. So from that perspective, National Water Mission and FICCI have embarked on these series to create greater awareness, to bring expert knowledge and insights, and to also showcase what the corporate sector is doing in this direction. We've seen excellent examples of corporate water stewardship in terms of rainwater harvesting, in terms of groundwater recharge, and various other initiatives across the country related to water conservation. Today, again, as we have had in the past 2 webinars, today as well, we have an institutional expert with us here, Professor A.K. Gosain. I will introduce the experts when the discussions begin. We have Professor A.K. Gosain from IIT Delhi with us. We have from the industry side, of course, Mr. Mukund Vasudevan, who is the co-chair of the FICCI Water Mission, and he's the MD of Ecolab India. The other 2 experts from industry also that we have here today with us, again, 2 of them who will be bringing an excellent insight on what corporates are doing. We have Mr. Anand Kumar Rai from JSW Steel and Mr. Arpit Vijay from Asian Paints. Again, 2 very diverse examples from 2 very different sectors that we'll be showcasing today. So without further ado, I would request Mr. Mukund Vasudevan, co-chair of the FICCI Water Mission, to make his opening remarks. Mr. Vasudevan.
Thank you, Rita. Just a quick sound check. Can you hear me?
Yes.
Okay, perfect. Thanks again, Rita, and welcome again to the panel, Shri Ashok Kumar and Professor Gosain, welcome, and our industry expert, Mr. Arpit Vijay and Mr. Arora. Right? So thank you so much for being participating in this series. I think this partnership between FICCI and the National Water Mission and the Jal Shakti Ministry has been immensely useful, powerful. A lot of attendees. Even today, we see almost 100 attendees. And I think it's an indication of the importance which water is getting. It's an indication of why India, everybody knows, all the people in the audience know that India is a water stressed country. And it is not just for the sake of sustainability or CSR that we need to look at water, but it's also in terms of continuity of businesses, of communities, and our country as a whole. That this has become an important factor. In my job, day job, I represent Ecolab, which is a company which does a big portion of that is around finding ways for companies to reduce water consumption. And we interact with many, many industries. And across the board, people are beginning, our customers, companies, industries are beginning to say, this is no longer a nice to do. This is no longer something for sustainability's sake. It is a business imperative. In fact, there are companies which are now saying this is in their top 5 CEO agenda. It is that important. So what exactly do we mean by reduce, reuse, and recycle? I think there's lots of experts in this panel who will talk about it. But at the highest level, reduce is about reducing consumption. So the first step is around demand management. Without demand management, it's going to be very, very difficult for us to continue for many more years with sufficient water. And we can forget things like Make in India if we do not have enough water. So this all ties together. The reuse is about finding ways to reuse the water with a little bit of treatment, whereas recycle is around recycling the effluent, which is coming out of a factory or out of a building, to completely reuse it back into the factory. The other reason why reduce is so important, it's the first leg of this journey, but it's so important is as you move between reduce, reuse to recycle, it gets more and more expensive for every industry and sometimes unviable because it's so expensive. So from that perspective, reduce is the first thing which all of us as industry participants should do, or even commercial buildings, or for that matter, even farms, we should be thinking of doing. Of course, not everything can be done through reduce. There has to be opportunities which we have to look at in recycle and in reuse too. The other thing which plays in this is the government's role, and there I think there is a lot of talk about incentives, the right kind of incentives. This is a scarce resource, similar to how the government has done a fantastic job in creating the right incentive structure for renewable energy to be used by industries. Similarly, we are advocating as FICCI, and government is also trying to do its bit already as some incentives, but we probably need more to figure out how we can recycle, but yet be provided with the right incentives as industry to recycle. I think it can be a win-win if we do that. So this is a multi-stakeholder game here. It is us, industry participants as users who have to reduce, reuse, and recycle. It is the government which will have to find ways to encourage industry and other consumers of water to reduce, reuse, and recycle. And finally, it's a community. The community, especially in rural areas, may not be able to put in the right technology, or it may not be able to pay the right price for water. There has to be a little bit of cross subsidy to make this all viable. So the last thing I will say is, since it's a multi-stakeholder game, you have to look at this as a basin level. You cannot look at it in isolation as within your factory or within your domain. It has to be within your factory, outside your factory, not just the immediate vicinity, but the entire basin. How do you reduce consumption from the basin? How do you reuse within your factory or around your factory, between factories also within the region? And finally, how do you recycle back to the ground so that the basin is aquifers are continuously recharged? Lot of interesting topics to discuss here. I look forward to hearing the experts speak more than myself. So thank you very much again for participating. I look forward to a very robust discussion. Back to you, Rita.
Thank you very much, Mr. Vasudevan, for those very important insights that you've laid out and really sets the context for discussion on 3 Rs and very rightly pointed out the need for multi-stakeholder engagement and therefore larger basin level approach opposed to an individual unit level approach. Thank you so much for those insights. And now I would request Mr. G. Ashok Kumar, Additional Secretary, Ministry of Water Resources and Mission Director of the National Water Mission, who's really been instrumental in initiating the Catch the Rain campaign to make his address and presentation. Over to you, Mr. Kumar.
Thank you, Rita. Thank you, Mr. Mukund. And I see experts on the panel who are with us in many fora in the National Water Mission Awards and other water talks, and Professor Hussain is there. So welcome all of you. I thank FICCI for the good initiation which we have started on this. This is the third of the water talk or third of the seminar series which we have initiated, and it's a very it's going on well, and we are very happy the way it is in progressing. I'll take 1 or 2 minutes to tell about the National Water Mission, because National Water Mission, though formed in 2011, had not been in the finger of health for last 7-8 years. It has now picked up a lot of activities in the last year, maybe a year or so. Professor Hussain is aware we had the first National Water Mission Awards won on September 25th of last year, and he was one of the eminent jury. And we had nearly about 45 lakh rupees worth awards were given, and we had good entries. And we gave awards for the individuals and organizations who were doing a lot of good work on water sector and the goals of the National Water Mission. Water Mission has 5 basic goals. That one is the comprehensive water database in public domain and assessment of impact of climate change on water resources. Second would be on the promotion of citizen and state actions for water conservation, augmentation and preservation. And third is on the focused attention to vulnerable areas, including overexploited areas. And fourth, very important, relevant to our topic also, is increasing the water use efficiency by 20%. And fifth is promotion of basin level integrated water resources management, which spoke about. So these are the 5 major goals, and we have about 39 strategies associated with it. We also started a series of water talk on 3rd Fridays every month. To do a water talk from since March 22nd, 2019. Every 3rd Friday of the month we have a water talk, and last 3 sessions we have switched on to e-water talk, and I'm very happy to inform that last talk Mr. Mahesh Sharma of Jaguar, he had the talk, and we had almost 39,000 participants. It's a very good response we got. And we also do a lot of other things like the state specific action plan preparation, water audit of water and industries, and we also now move for the national water use efficiency. I'll come to it later. So these are some of the various activities the National Water Mission had been doing, and it's here. So one, in the last 3 meetings, we were trying to focus on a couple of myth-busting exercises. First one, we thought that we will say that agriculture is the one which actually uses more water, because many times our focus is on drinking water, and we all think that domestic water actually uses most of the water. That was the first myth we wanted to burst, and we did that in the first batch, telling that 89% of the water usage in India is in agriculture sector, and hence saving in agriculture would mean a lot of saving of water in volumetric terms, and that's one thing we busted. And second one was about on the surface water versus groundwater. Our usage of groundwater is very high compared to surface water, so that's another thing which we talked about in the second session. And today the industry uses about 5% of the water, but then they can also do a substantial change, reduction of water usage, and we look at various aspects of the industry and water in this today's session. But before going to that industry part, I would like to involving and indulge you in one important campaign which we are doing. On the campaign, as Rita mentioned, this is about Catch the Rain. So we have come out with a campaign called Catch the Rain, Where It Falls, When It Falls. Basically, all the three are important. It is a supply side management side. As Mr. Mukund said, India is not a water deficient state, it's a water stress state, and that is because of the poor water management. So we look at the demand side in the industry and agriculture separately later on. But looking at the supply side, we have rain as the major source of water in India, and we get very 3-4 months period only rainfall, and that rainwater has to sustain for the next remaining periods of the year. So we have unfortunately very poor water storage. Not ability. We are storing very less water, about 8 to 10%. That's what the records say. So most of the water which we get from rains are actually flowing down the river to the sea and is get wasted. And we have a lot of places having water stress in the month of summer and a later period after the rains are over. So we have come out with this campaign called Catch the Rain, Where It Falls, When It Falls. Our idea is that we should have a decentralized system of storing the rainwater, not in big dams, because that was the earlier model. We thought that we could construct huge dams. They were the modern temples, as Jawaharlal Nehru said at that time, or former first prime minister. We had the concept of building huge dams, storing that water, and then releasing for the purpose of irrigation and other drinking water purposes. But that has now run into rough weather because of a lot of environmental issues associated with it. There are issues due to inefficiency of the dams created. There are inefficiencies of the transportation of water from the dams to the fields. There are many things which are actually tilting the scale against the huge impounding of water. So the best way is to decentralize storage of water. This in turn will improve the water, soil water moisture. This is a very new concept where water, instead of being stored in dams, we want to store water as soil water moisture. This will slowly release the water, and it will release it for over the years. So the water usage or uptake by the plants and all will be maintained throughout the year. So this is what the latest thinking of using water moisture as the main source of water storage. So Catch the Rain is actually a decentralized form of storing water where it falls. We don't want to transport it somewhere else and store it in bigger dams. We have to store water and soil moisture in the place where it is itself. So, and our idea is that if water in a compound is stored in that compound, it will not flow out to the roads and create havoc. Yesterday, many of us have read the problem which the rainwater has caused in many parts of the Delhi. Indo-Eu Bridge, every time when there's a rainfall, it gets flooded. And this time, unfortunately, one person died because he got stuck in a vehicle in that water which submerged that area. Now, if rainwater is caught and stored in, or it is impounded in your own compound, this water would not have come out to the road. And the roads and the stormwater drains, which were actually designed to carry water falling in the road area, not be overflowing, because what happens is many of the compounds which we have now have become concretized and tiles have come up, and all the water flowing there is coming out on the road, which is causing havoc. And the area which was supposed to store this water coming out, the water storage areas, the small ponds and the lakes in urban areas are getting crossed upon because of real estate issues, and those storage areas also getting affected. The channels which bring water to the lakes and the storage water are getting affected. All these are contributing to urban flood. So the best solution to tackle the urban flood and to avoid situations which we faced in the last couple of days in Delhi and other many cities is to catch the rain where it falls, when it falls. That's the main campaign which we're doing. And we want that not a single drop of water, at least minimum amount of water only flows out from your compound. All the water has to be impounded there. Now, this is something like for industrialists, it's like a reverse of crowdfunding. In crowdfunding, what happens? Everybody puts in water, puts in money, and then it becomes a huge quantity. So now I am talking about a reverse crowdfunding, or sort of water crowd saving water. You don't save water at the last point where all the water gets accumulated and becomes a big, huge mess. You want water to be saved at the source. So it's a crowd sourcing. Every crowd source saves a little water, and that will not create havoc at the last point. So it is a reverse of crowdfunding. And we have now got very good endorsements from various leaders of the industry also, and the political leaders also. So before going on to the industry part of it, which will take 5 minutes, I would like to listen to the message given by the Honorable Vice President on the Catch the Rain campaign. Can you have the message of the Vice President? ऑडियो नहीं आ रहा है David, that is somehow last time also we missed this video part of it. Anyway, so this is an endorsement by the Vice President, and the Vice Chairman Niti Aayog also endorsed. So we want all the industry partners to come and join us in this campaign for the Catch the Rain Fund. Now, coming to the industry and water, as I said, industry uses only about 4 to 5% of water, and there is scope for reducing the water in the industry. Is it working? No, if it's not working, leave it. When we'll try it later on, it's not working. Okay, so in India, actually, thermal, the energy, the thermal sector, the energy sector uses about 87% of water. Engineering sector about 5%. Paper pulp about 2%. Textiles about 2%, and industrial about 1.5%. These are the various sectors which use bulk amount of water, which I mentioned, 5% of water. But our water usage efficiency is very low. In agriculture, it's also very low. In the industry, is also very low. So what we have to do is we have to increase the water use efficiency. The equation says that it should be a numerator is where in the output, and the denominator is input. So if you keep the numerator constant, we have to reduce the input if you want to increase the water use efficiency. That's where the today's 3 R's will come up. The reduce, reuse, and recycle. And the 4th R is also recovery. Is also people talk about it. So if you reduce the denominator, that's the water which is used in the industry, from taking from an outside source, then probably our water use efficiency can go up. And we also, our water footprint is also very high. For manufacturing of certain like a pair of jeans or a banian or a t-shirt or whatever it is, our water usage is much higher than what other compared to the other developed countries. So we have to work on that. So coming to the reduce, reuse, and recycle of the concept which we are talking about today, Water Mission had been doing water audits. Because unless we measure and meter the water, we will not be able to tell how much quantity of water is being used, or whether there's a scope for reduction. So water metering and pricing the water, these two things are also very important. So we are doing this water auditing in industries from the National Water Mission side. We are studying, and with the help of IITs and other technical institutions, we are doing some process re-engineering in industries like particularly paper pulp and hide and in steel industries, we have done a lot of work and which has helped in reducing the water intake. That is one reduced part of it. We can reuse the water, as Mr. Mukund said. The reuse part also is not really catching up here, but we have to do this reuse part of it. We can use multiple, water can be used multiple times. A simple example which we tell is about the RO water. RO water can be used, the output, the RO actually is about 70 to 50 to 70% of water is rejected by the RO. That water can be used to wash the fruits, and then it can be used to mop the ground, and the same water can be used for watering the plants. So same water can be used for multiple uses. So multiple use of water can be done in industries. We use, as Mr. Mukund said, we can we use the water for reduce the input of water we take from outside sources. We can recycle after processing. This is also one thing which now it's spanning attention, because the water used to be free of cost. So people were not really, industries were not really bothered about the cost implications of water. So now, because many states have raised and the public has really understood the value of water, many of them are raising concern for the overexploitation of water by industries. And that's why many people have now started using the concept of recycling of water, and zero liquid discharge norms have also come up. It's very difficult, but we are trying to move in that process. Treated water is another usage of treated water is one another thing which we have to take seriously. In Namami Gange, we tried to STPs in many places and have really got good quality, bath quality water, but there are no people who are willing to take those water. There's a mindset issue, and also we have to make this concept of using treated water as input water for non-potable purpose has to be taken up. So we have to do that ban on using potable water for any non-potable purposes. This is one thing which we have to do it nicely. And then if industry can join us in reducing the water usage in the industry for their sake as well as for the sake of the public at large, we'll be very happy. We are coming out with the National Bureau of Water Usage Efficiency. The value has gone up. We are trying to make star ratings, as is done for the energy efficiency, ratings on the products which use less water. We are also trying to make some regulatory aspect on the industries which are over using the water. And the last point I would say, industry generally have two issues associated with industry. One is, of course, the demand side, which we are talking about it. Second is about the pollution part of it. That we'll talk later on. Pollution is not it's of concern, but not of concern today in this particular webinar. The problem with pollution is 1 liter of polluted water can spoil or pollute about 10 to 15 liters of water. So we have to also do a check on the pollution of water from industries. These are the few thoughts I have. I wish that all the industries will join me and the National Water Mission in catching the rain where it falls and when it falls, and also look at the supply side of water and the demand side of water. Thank you. Thanks a lot.
Thank you, Mr. Kumar, for that extensive introduction on what the National Water Mission has embarked on, its key goals and priorities, as well as the entire campaign around Catch the Rain. And as always, you have highlighted the need to focus on water use efficiency in all the sectors and the reuse of treated water. So really bringing a circular economy approach to water is going to be central to all this. So thank you very much for your insights and the details that you've shared about the National Water Mission. Just before I go on, I just wanted to say that the FICCI Water Mission also focuses on the 3 areas of industrial water use efficiency, corporate water stewardship, and public-private partnerships in urban wastewater. And FICCI is also working with industry at the unit level for water audits, for various capacity building and training programs around water conservation, not just in India, also working extensively in Africa. So I just wanted to mention that. And before we go on to our panelists, I wanted to just mention the kind of participants that we have today. We have a very interesting mix from not just the corporate sector, a very large representation from the business and industry side, but also from municipal corporations, from different institutions like IIT Roorkee, National Institute of Hydrology, the National Institute of Technology, various universities also who are participating here. We also have NGOs and both Indian and international NGOs who are present here today. So a very wide mix. Also the CGW and CGWB officials who are here, and some of the corporate foundations who are present in this discussion. So very wide and diverse set of stakeholders that we have present here. So now we move on to the talk by our experts. And
can we just play that video again? We'll just try once again.
Sure.
In many Indian languages, the word for water is Jivan or life. We cannot think of life without water. It's a scarce natural resource that sustains all of us. But we don't have unlimited supply of water. India has about 18% of the total world population, but only 4% of potable water. This means that unless we conserve this precious commodity, we'll face a major crisis soon. We cannot allow that to happen. All public institutions, government offices, universities, IITs, colleges and schools must take lead, and every house must have rainwater harvesting. Both in urban areas and rural areas, rainwater harvesting system must be made mandatory while sanctioning plans. We must ensure that water is not wasted and the groundwater reserves are recharged when the rain falls on the ground. We must catch the rain and store it. We must revive our indigenous water harvesting systems and village tanks and ponds. Drip and sprinkler systems have to be promoted in a big way. I'm happy that the National Water Missions campaign is taking up a timely initiative called Catch the Rain When It Falls, to take concerted action in this direction as and when rain falls. Water conservation must become a societal mission like the Swachh Bharat Abhiyan. There is no better way to secure our future than to save every drop of rain. स्वच्छ भारत अभियान की तरह जल संरक्षण को भी एक जन आंदोलन, जन अभियान बनाना होगा। भविष्य को सुरक्षित करने के लिए बूंद बूंद पानी का संरक्षण करने से बेहतर कोई तरीका नहीं हो सकता है। जय हिंद।
Thank you very much. And I think everyone noticed the hashtags, hashtag catch the rain. And we request all participants to use this hashtag so that there is much more amplification to this campaign going forward. I also want to mention that the nominations for the FICCI Water Awards that we do annually is right now going on. And those of you from industry who are present here today, you're most welcome to send your interest for nomination to the FICCI Water Awards at watermission@ficci.com, watermission@ficci.com. Thank you. And now we'll move over to the next section, which is our experts talk. And I'm delighted to introduce Professor A.K. Gosain. Professor Gosain is an emeritus professor in the area of water resources engineering and GIS technologies in the civil engineering department of IIT Delhi. He is also an esteemed member of the FICCI Water Awards jury. Professor Gosain has pioneered several things and has many contributions to his credit. Some of these that I'd like to mention here today. He has pioneered the climate change impact assessment on Indian water resources that was incorporated in the National Communications NATCOM 1 and 2, made to the UN Framework Convention on Climate Change. He has also contributed to the formulation of the Ganga River Basin Management Plan, which he led as the team leader. He also formulated the Drainage Master Plan of the National Capital Territory of Delhi for the Delhi government. He is an expert committee member of the National Green Tribunal as well. So there are several distinctions that Professor Gosain has, and we are delighted to have him here with us. So over to you, Professor Gosain.
Thank you, Rita. Mr. Ashok Kumar, Mr. Vasudev, and all the other distinguished panelists. I would like to get into, I am going to use share my screen. Can you see my screen now?
Not yet, but I guess it'll come up. Not yet. Yes, I think it's, yes, now we can see it.
Okay. So I'm going to talk today about, besides the many various kinds of conservation measures which we are talking about at the level of industry, at the level of domestic water usage, as well as the agriculture use. I feel there are some issues which still are not explored very much, and I'd like to dwell on some of those. But let me start with basically creating the context that why we have reached at the present state of affairs where we are. And as has been said by many people, that the demand imposed is much more than the availability. That's the root cause. So we are talking in terms of reducing the demand, but mainly the demand reduction is one aspect. We have no clue at this juncture how much reduction in demand. So there has to be a framework. There has to be a mechanism in place where we can evaluate that how much is the reduction which is required at this juncture. We'll think of climate change implications as we go into that era. And this is not only in one or two basins, almost every basin, as we have, as has been discussed in the previous sessions also, that we have the falling water tables in every basin. And that is implying that there is a deficit. We are drawing more water, which is our storage, the groundwater storage, which is supposed to be very judiciously used under those circumstances when we have situations where there's, the rain has not come, or we have a deficit, we have a drought kind of thing. But as of now, we are basically using this resource very in a very, I'll say, improper manner or unjudicious manner. The reasons are many. The reasons are basically that we have never evaluated how much a particular basin has the water resource to be offering to the society. We always talk in terms of the total water resource available at the country level and then divide it by the numbers and then say per capita, this is what we have. But that's not the way I think we should be looking at this very precious resource. It has a variability, it has variation. People in the Rajasthan cannot think in terms of using the same amount of water which another state, which is abundant with the water resource. They are naturally getting more because of their placement where they are, where their geographical location and the situation in that basin. So the Ganga basin had so much water, but still we have brought it down to a level that there also we are having a similar situation, that our demand is imposed as much more than what it can afford to provide you. So we don't talk of the trade-offs between the competing demands. How much is the overall demand we are imposing on that basin? That is the major key requirement which we need to really take care of. Unless we do that, we will find it very difficult to really take care of the problems which we are facing, which our society is facing. Another thing which I like to just mention, that we have been using this slogan for quite some time, that let's stop the rain where it drops. I think that will be very, I'm just posing a warning that if we don't use it in a proper manner by looking at how much is the amount of water which you need to conserve from the rainfall in that particular area, in that particular basin, after reducing the demand, because first priority has to be reduction in demand. So if there is still some demand which is left, that you might be in a position to circumvent or supplement through the rainwater harvesting. There are various ways of rainwater harvesting. Why I'm saying so? Because anything you do, any structure you create, big or small, whether it's a dam or whether it's a check dam or whether it's a small pond, it has an implication. Because that is the water, you're not generating any new water. That is the water which was going elsewhere earlier. Now you're stopping it. So we have to really analyze very scientifically again that what will be the implication of stopping the rain where it drops. It might make many of your small streams dry altogether. It might make many of your projects, which are the existing projects, big projects or small projects, be devoid of water. So that will create another series of problems which we cannot afford to have. So I think this slogan has to be very judiciously used and very scientifically analyzed, and the trade-offs have to be set for each basin, that what is the maximum amount of water for a particular basin which can be conserved in this manner. The first priority should be still the reuse, the reduction in demand, and this should be the last priority as per my recommendation. So, and then secondly, by doing so, you might also disturb many of the ecologies, many of the environmental services might be stopped. That is very important. So we need to assess what is the environmental demand of the flora and fauna of that particular system. That has to be released, that has to be conserved, that has to be made available, which we have taken over the years. And I think we are seeing the ramification of that, and we are seeing the implications of that. That is again another thing which is very important to be looked into. So the sustainability, we come to that. Basically, this is what we call of sustainability. And sustainability in the present context is basically looking after the hydrological health of the system as well as the environmental health of the system. So when you are taking away the water, the environmental water, which is the requirement of the flora and fauna, then we are reducing the environmental health of the system. We are doing the groundwater mining. We are finding that the groundwater tables are going down and the rivers are losing water to the groundwater. That is something which we need to really plug those issues, and we have to really take decisions. This is only a template which I have shown that there's a natural system. So we are now we are talking of the basins, the catchments, or the natural areas, whatever name you give. At the different scales, the nomenclature is different. When we do the interventions, it's important to understand that what are the implications of the interventions. So that brings us to a situation where we need to take these actions, the series of actions, system by system, river basin by river basin. We need to first find out what is the available resource, temporally as well as spatially in that basin, and what are the demands present as well as the future demands. Are they matching? Is there a deficit? How much is the water use? Then you can start looking into that, where we can reduce the demand by enhancing the water use efficiency. So we'll have to evaluate the water use efficiencies of various usage, whether it's agriculture use or whether it's a domestic use or whether it's industrial use. What is the environmental status of that basin? And what are the development pathways? When the climate change will come, what are the situations going to be in the coming years? Is this area going to get more water, or is this area going to get less water? If it is going to get less water, then we'll have to further reduce the demand because we have no other option. If the area is going to get more water, it might be having associated other situations of the flooding. It might create more floods. So how we are going to cater to those issues of enhanced floods, as we are seeing that the intensity of rainfall is increasing, whether it's the townships or the basins, the rural areas, we are having implications, and we have to be ready to look after those implications. This can all be done if we have the proper informations generated. And our group has been really doing this for the last many years now. We started with the climate change implication on the water resources of the country. And we have been using the hydrological modeling, which is basically mimicking the nature, that what the nature is doing, what are the processes of the nature, when the rain comes, where that water goes, depending on the land use, depending on the soil type. So we make use of all these characteristics of the basin and characterize the basin, and then try to simulate that if the rain will come, how much will be the flow generation, how much will be the soil absorption, how much will be the groundwater recharge, how much will be the evapotranspiration, looking at the local climatic conditions. And that is a very good tool. So while doing the work for the Ganga River Basin Management Plan, we had showcased that some of the things which wouldn't have been possible otherwise earlier. These are some of how we divided the whole basin into smaller basins, and then how we simulated each smaller area. And ultimately, we came out with revealing things. For example, if now we are talking of that we should reduce the usage of groundwater. The groundwater tables, the top two slides on the left and the right, are showing the present groundwater tables in the pre-monsoon conditions and the post-monsoon conditions in the Ganga River Basin. But if we want to restore them, if we want to enhance that through the rainwater harvesting or by taking various decisions to bring it back to the pristine conditions or closer to the pristine conditions, then we have to have that knowledge. So through the modeling, we generated this information that what would have been the groundwater tables if we were not pumping the groundwater, if we were not diverting the surface water, if we were not having the other implications which we have, the man-made implications, if the system was natural system where the groundwater table should have been under the pre-monsoon and the post-monsoon conditions. So this is what the science gave us. We used that, and then we did the groundwater modeling along with it and tried to find out what is the implication of the excessive groundwater abstraction from the for various usage. And we identified which are the segments of the river, the Ganga and its tributaries, which are now losing water to the groundwater. Because the groundwater table has gone so low that there is a gradient which is set up from the river to that lower groundwater table, and the water is moving from the river to the groundwater. which is a very unnatural thing, which is not, should not be happening, because the perenniality of the ground, the rivers, most of the rivers come from the contribution coming from the groundwater, because the groundwater table goes up during the monsoon, and then it starts contributing during the non-monsoon period slowly to the rivers, and they remain perennial because of that. So we are, because of our actions, we are losing that perenniality in some of the segments, and not only in Ganga, but in some of the other rivers also, it is happening. I will like to bring in now one more contribution which we have made, and this is a best case of Make in India, where for the first time I have not seen such a site where people are, or any countries, doing the real-time flood forecasting using the rainfall data, the rainfall forecast given by IMD. Now this is the portal which we have developed with the, this whole thing has been done by a company which is was incubated by the IIT system long ago. Is my extended group, is known by the INRM consultant, Integrated Natural Resource Management Consultants. They have put this together, and IMD has provided the data, which is the next. IMD gives the rainfall forecast every day. They issue the rainfall forecast of the next 7 days for all the areas of the country. That rainfall data we are picking up, and we are basically let me just take this. Yeah. So if you see this, I can pick up any of the basin. If I pick up a basin, I have picked up Godavari Basin. And this is the monsoon, and what it's doing is that is loading the Godavari. It's an online system, and anybody can have a look at this particular portal. We are, every day we are simulating the whole country daily with the revised information of, so the Godavari has been picked up. If you want to see that how much is the rainfall which has occurred in the last 2 days in Godavari, this is what the various areas, you can see the legend here is showing that which area has got how much rainfall occurred and on the day, which is 21st July. And if I want to see what is happening on 22nd, which is today, this is the situation. And the forecast, the rainfall forecast which IMD has given, I'm not putting in series, it is going to show me 23rd July, 24th July, 25th July, and so on. What is the rainfall which is going to come in this particular area as a forecast given by the India Meteorological Department. So we have used that data taken from the IMD and run the hydrological models for these basins and all the basins of the country. And now I can tell various things. And this I'm just showing that what is the stream flow at any location in the Godavari basin. At this location, the stream flow is 1,107 cumex. But I can also see that what is the pattern, what is the hydrograph. This is that yesterday and today's rainfall. These are the rainfalls of the next 6 days. And this is the hydrograph that the flow on 25th of July at that location will be 2,800 cumex or so, 2,900 cumex. I can go to any other location and I can have a look. So you can see any location. This is the lower location. Here, the discharge will be around 12,000 cumex on 24th July. So this is the generated flow using all the information, and it also gives, it can be shown in a tabular form. You can see that what is the discharge, what is the rainfall on different days. We have also given that what is the Varis code of this, how much is this area of the basin at that location, how many projects we have incorporated. There are 156 projects. We have incorporated 107 projects. The other projects have not been incorporated because of the lack of data, but they can also be incorporated. Now, if you see this is such a huge thing. It's such a huge effort. I have not seen any country having this kind of thing available where you can issue the rainfall, the real-time flood forecast for any location of your country at any time. So is even working during the non-monsoon period, is showing at that time what is the, I can show what is the soil moisture at any time. It's showing the soil moisture on that particular day. It can also show this, how the soil moisture is going to change on other days. And there's no, I feel that so many other things can be done besides the, I'm sorry, it has picked up. I clicked at the wrong place, so Mahanadi has been picked up. So anyway, I can show for Mahanadi what is the soil moisture. So the soil moisture for Mahanadi is changing from day to day, and how it is changing. So this can be used very effectively by the farmer. Now coming back to why I'm bringing in this whole concept of conservation. This is very much connected to the conservation, because through the modeling, we have basically modeled all the water balance components, the soil moisture status, the stream flow, everything has been picked up. You can even see at any scale, you can even enlarge it and see the smaller areas, how those areas are. Each stream is visible. And while implementing the reservoirs which we are having, the big structures which we are having, they have also been simulated. Now coming to the situation that normally when we are storing water in the reservoirs in the monsoon period, once the reservoir is full, we always operate it in such a way that we keep some flexible storage in the reservoir, so that if some big flood comes, it shouldn't have, its structure shouldn't be endangered. So that can be avoided. Many times we might be releasing more water, and ultimately by the end of the monsoon, we don't have the reservoir full available. Now the conservation can also be of the kind that if we know through this kind of approach that at that location, in that reservoir, how much is the expected flow, because of the rainfall forecast, how much is going to come, I can keep the reservoir ready by reducing that much water from the reservoir, so that by the end of that event, the reservoir is full. So you have conserved water which you could have wasted otherwise and couldn't have retrieved and couldn't have used for your irrigation purpose for which the reservoir might have been constructed. Similarly, from the farmer's angle, if we really want to have the demand management of their water use, their efficiencies, we have to showcase. So in this modeling system, every crop can be simulated. We can know that how much is the yield you can get from the crop if you provide this much water at these times. And this is the fertilizer which should be used effectively. You can find out how much is the yield you are going to get. So you can showcase to the farmer that the additional water which you are using is going waste, is not going to be of any benefit to you. You might be using electricity to get the water from the groundwater, and it can be avoided. It can be showcased to them. So I think if you can showcase through the simulation approach, you can tell them and advertise that this is what is, and even the policymakers, if we can tell that this is for this particular area, for this particular crop, this is the right amount of fertilizer, this is the right amount of pesticide which should be used, you can reduce the non-point source pollution. You can also effectively enhance the water use efficiency of the water use in the agriculture by showcasing that this is the right amount of water, and many more things. Under situations when you will be basically coming back to the a situation where you want to plan that under the climate change situation, this is going to be the amount of water, which is a reduced amount of water. What kind of land use you should have, what kind of cropping pattern you should allow. Those things can be simulated, it can be produced as a range of outputs, as range of scenarios, which can be fed into the policy making instrument, policy making effort, and your policies can improve much better. So I think there is lot which can be done through this kind of thing. I'm just going to skip all these things. We have implemented this on the Manadi system. The Orissa people are using this. This was done around 3-4 years ago for them, and is much better forecast because it uses the rainfall forecast, and also it uses the rainfall runoff conversion process, which is a much more sophisticated option. Do I have a couple of more minutes?
Maybe another 2 minutes, Professor Gosai.
Yes, fine, Rita. So I think that is one thing which we have done, and we are still waiting for the proper dissemination of these things and proper usage of these things. And since Mr. Ashok Kumar is here, I'm sure that he will maybe give us opportunity to really make use of these opportunities in some of the real manner and in a more effective manner. Another project which he has just taken up recently is the Indo-Eu Project, where the funding is coming from UK, and it was bidding, and it was very, very prestigious thing with the University of Newcastle, where we are looking at the water security and sustainable development. And the case which we have taken is the NCT of Delhi, since we have already worked on Delhi. Here we are again very systematically going and looking at various aspects. We are taking the whole basin, the Yamuna is the basin because Delhi is on the Yamuna, in the Yamuna basin. And then coming from Yamuna and looking at what the Yamuna has to offer for the present and the future, how we are distributing the water. And then after looking at those aspects, we are coming down to the NCR. What is the relationship of the water between NCT and the NCR? Because NCR was formulated for the purpose of having that integration of these kind of common resources to be taken up in a proper manner. And then coming down to the NCT, NCT will look at in a very detailed manner what is the water balance of, what is the water audit of NCT. It's a very, very gigantic task which we have taken on to ourselves. And here we are basically within the NCT also, we are taking Barapula as a basin where we are looking at in a very detailed manner the infrastructure, which is the water distribution infrastructure, the sewerage infrastructure, and the drainage infrastructure, the stormwater drainage infrastructure, because these three interact very effectively. And then coming out with how we are presently managing these three infrastructures and how they should be managed properly, what interventions are required to be taken up in the scientific designs. And we have some groups which are basically socioeconomic groups. People of the SPA are also involved in this. And we have some other NGOs which are involved in this whole process. And seeing the water security from all angles, the quantity, the quality, and all those things. So this is a project which has started last year and is a 5-year project. And I think there's a huge opportunity to engage with this project, all those people who really want to understand the completeness of these initiatives and the integration of these initiatives, how they can actually happen and how effectively can not only think of these solutions, but implement these solutions and participate in the implementation of these solutions. They can come forward, and we'll be very, very happy to engage them in any way they want to be engaged. But in the end, this is my last slide, that the use of hydrological unit for planning is very, very important. Mapping of all interventions is important if we want to take action, because first we'll have to understand what are the implications they have created, and then we can think in terms of taking care of all the ill effects which have come about and how we can resolve them. Assess the availability of water resources, assess the total demand imposed, plan for demand management if there is deficit, create evidences through observational networks. So we have to keep on observing. The science has to be used. The observational networks have to be very good, and we have to keep on evaluating and learning and going forward. Thank you much.
Thank you, Professor Gosain, for that very insightful presentation and detailing out this whole river basin management plan and the master plan for the NCT of Delhi, which is very interesting. But I think the few insights that really captured my mind here today is the fact that you spoke of trade-offs, and that is so important in the context of water allocation itself, but trade-offs from a basin approach, which will be very, very important to take into account. You spoke about the need to look at the environmental demand. So the balance in terms of how water is allocated between different uses, as well as taking into account what is the need from the flora and fauna point of view, is going to be equally important to maintain the environmental health of the ecosystem. And you also spoke about the interface between the natural watershed and the managed systems. I think that's also a very key takeaway. And last but not the least, the need to develop a river basin approach is what you spoke of. It's also very interesting what you highlighted about the real-time forecasting that is available today, and really a pioneering initiative. We must congratulate you for that. For this important initiative that India has come up with. So thank you very much once again, Professor Gosain, and we look forward to some of the questions that are directed to you later on. I'll now move on to our next expert now from the corporate sector, Dr. Anand Kumar Rai, who's the General Manager and Head Environment of JSW Steel, the Dolvi Works. Dr. Rai has a very rich experience of 20 years in many different sectors like cement, mines, power, steel, and besides other environmental areas, he has strong expertise in water treatment plants, in water pollution control, in environmental impact assessment, biodiversity, and other areas. He's done an MTech in environment along with a PhD in biological sciences. So over to you, Dr. Rai.
Thank you, madam. Thank you. Yeah. Just let me share my presentation first. Good afternoon to all respected panelists and all participants. I would like to share the initiative taken by the JSW Steel like Dolvi plant, which is near Mumbai, in terms of what kind of activity or actions we have taken for water conservation or technological or water reduction through technological improvement and so on. So this is our just at a glance for process flow of steel industry. Basically, all the industry are having a similar kind of processes. The main raw material is using iron ore and coal. Then some fluxes are also being used. So iron ore is used for making the pellet or sinter. Pellet is basically, it is a pelletizing process where beneficiated iron ore is converted into small pellets, ball-like structure, which is size is approximately 9 to 12 mm. Then similarly, sinter, there is also iron ore plus other kind of fluxes are mixed together and form a sinter. And these two material is basically the primary product of the steel industry. Then coking coal is used for making the coke for coke oven, and byproduct gas which is produced from coke oven is coke oven gas, which is used for the power generation. So this pellet is charged in DRI plant, dry reduced iron plant, sponge iron plant to make a DRI, and also in blast furnace. So in the blast furnace, pellet, sinter, and coke is charged for making the hot metal in the blast furnace, and this hot metal shifted to the steel melting shop to make a liquid steel. And if there is some impurity, it is removed by adding the limestone. Then this liquid steel finally come to the ladle furnace. So based on the market demand or different kind of product, this ladle furnace is used and liquid steel form. And we make a different kind of product like hot strip. In hot strip mill, hot roll coil, then billet caster or TMT bar. So this is the basically process where in entire process, the heat is involved. So plenty amount of water is used for the cooling purpose or different kind of purpose. So if you look at the water consumption in entire process, so cooling network is the major process where 45% water is being used in all furnaces, and the cooling of all machines where high temperature is there, and also in hot strip mill and bar mill where the product is coming out in a hot nature, and then the water is used for the cooling purpose. Then in scrubbing system, followed by scrubbing system where the gas is being cleaned, like blast furnace gas is being cleaned, and also in SIP or hot coke through this water. So 26% water is used in scrubbing system, and 11% water used in water quenching, where hot either product or waste material is coming out from the process, and through quenching the material get cooled. Then 3% water in process requirement, and then 3% boiler, and the rest in firefighting and in others. So the goal is, or strategy, to reduce specific water consumption from 3.31 meter cube per ton crude steel to 2.5 meter cube per ton of crude steel. For that, we have adopted the Roth approach, where recoverable loss and opportunity, then theoretical and ideal loss. Through this, we will reduce the specific water consumption. In recoverable loss, we have reduced as of now 10% water by preventing the leakages and reusing the effluent in secondary as a secondary water in different processes like slag cooling and coke quenching. In the opportunity loss, basically we have identified and selected some good less water consumption technologies like dry GCP, dry gas cleaning plant, and CDQ, coke dry quenching, and some filter press. So through process optimization and improvement, approximately 6% water we will reduce. Then now whatever water is remaining, so 5% water we will reduce through theoretical losses by installation of RO or because a CTP, and rest it is under R&D stage, like to reduce the ideal loss, approx 2.5 meter cube per ton of PCS would be achieved through process innovation. So just I would like to share what kind of technology is there for less water consumption technology, that is in blast furnace. In existing blast furnace in entire, in India, we are using a wet scrubbing uh, system to removal of the dust particles from the blast furnace gas, and that waste gas is now converted into clean gas for using the using the blast furnace gas. So in the whole process, approximately 40 meter cube water per hour is being used. Now in dry GCP, this is the first time in India. Like our plant is JSW Dolby is going to install. It is under commissioning stage. So by installing of this technology, approximately 50% of water will be reduced. And in this system, gas would be passes first through bag filter, and after that, and the dust particle will be removed, and the rest of the component will be scrubbed through the spraying tars. So this is the system for which we are reduced approximately 50% of the water in blast furnace. And this is the second technology, that is CDQ. It is also a very new technology. Earlier, or even existing in coke oven, the hot coke is getting cooled by the wet quenching through water, and whatever steam is generated through wet quenching is going to the atmosphere. Now, in the new system, when we install CDQ, coke dry quenching, the gas, the hot coke would be cooled with the nitrogen gas, and the steam, whatever would be generated, will be used in a boiler and get it to convert into the power. Approximately 70 megawatt power would be generated. So approximately 0.5 meter cube per ton of hot coke water would be saved. So these two technology, major technology, which we are going to install, or it is under installation stage. So by this, we will reduce the water. Then as a reuse of the water in different plant of the steel industry, like there are different kind of plant. So as I said earlier, there was different kind of process, like cooling tower blowdown, then some non-critical process. So a different kind of water would be used in different application, like cooling water blowdown would be used in slag cooling, because there is no need of pure water. Cooling water blowdown water can be used, and coke oven water would be treated in BOD plant, and that would be recycled and reused again. So this is, by this we will reuse entire water of the steel plant. Then our last and final process of the water conservation is recycle. In this process, whatever water is left out, we will channelize all the water and collect at the same place, and will be treated in a common effluent treatment plant by using RO, and finally by installation of multi-effect evaporator, so that we would be able to recover more water, so that we can utilize more and more water, more and more wastewater after treatment, so that fresh water would be reduced. So this is our plan of doing. Thank you.
Thank you very much, Dr. Rai. I think it's a very, very interesting presentation of how JSW Steel in the unit in which you are heading is looking at all three aspects of reduce, reuse, and recycle, and how the company has taken a conscious decision to move to upgradation of technology to reduce the water demand in the first place. So thank you very much, very insightful and a great example of how water use efficiency is being looked at a corporate level in the steel sector.
Thank you, madam.
Now we'll move on to our next. We'll now move on to our next speaker, manager at Asian Paints. And he has been serving this post in the Roth plant of Asian Paints, which is the largest paints manufacturing facility in the world, and has extensive experience on environmental legal compliances, CSR, and environmental improvement projects. So over to you.
गेट खोल दो. हेलो सर, गेट खोल दीजिए, बंद हो गया. हेलो. Thank you, Ms. Rita. Good afternoon, everyone. I would start with the presentation. So I'll just switch on. Is it visible? Ms. Rita, if you can, yeah. Yeah. So I'm Arpit Vijay. I'm handling role of Environment and Sustainability Manager at Roth plant of Asian Paints. I'm joined with Mr. Mahesh, who is Senior Manager Environment and Quality at Asian Paints. I would be focusing on 3 R's of water conservation. The specific actions that we took at Roth plant for reduce, reuse, and recycle. We'll start with the company brief. Asian Paints started in 1942, started with manufacturing of paints, expanded as home decor company. Asian Paints is market leader in paints since 1967 and Asia's 3rd largest paint company with a turnover of over 20,000 crores. Operations span in 15 countries with 26 paint manufacturing facilities in the world, serving 60 plus countries worldwide. Asian Paints is a ISO 9001, 14001 and 45001 certified company. If I look at the financial performance, standalone revenue stands at over 17,000 crores and profit after tax would be around 2654 crores with a market capitalization of over 1,60,000 crores. Now looking at the Roth plant overview. So Roth plant is the largest paint manufacturing facility installed at one location in the world. Year of establishment is 2010. This is water-based paints plant. Total area of factory is around 130 acres with greater than 33% of green belt area. To give you a context of the last year's production and water demand, production was around 1.74 lakh KL, and which the water demand was around 1.55 lakh KL. We have installed solar capacity plants inside the premises as well as outside. 3 megawatt plant is located inside the plant and 6 megawatts utility capacity is there. So also we have rainwater harvesting structures in the plant catering to 8,320 KL of capacity. The water source, so paints industry is a water intensive industry and the water source for Roth plant is canal water. Now looking at the performance, environmental performance. So we'll first look at the water consumption pattern of the plant. 68% is for industrial purposes, which includes paint processing, water used in the paint processing, and the allied services like cleaning of transfer lines, vessels. Then 20% is utility and other services, and 12% is domestic and drinking. So the way we approach water reduction measures inside the plant. So we divide water into 2 aspects. One is processed water, which goes into the product. Another is non-processed water. So over the years, we have seen 43% reduction in the non-processed water consumption. So the numbers that we see is in 2013-14, we were at 0.56 kiloliters of water being used for non-processed activities per KL of paint produced. And by last year, we have achieved 0.32. Looking at the industrial effluent generation, we have seen a significant reduction where we have received 78% of reduction from 51 liter per KL of paint produced to 11.606 liter per KL of paint produced. So every year we have specific efforts in sustainability. So the numbers that we have seen, the actions that we took to achieve these numbers, we'll be discussing about them in the coming slides. So the approach that we use for environment improvement projects is reduce, reuse, and recycle. Our major focus is on reduce. So the actions that we'll be discussing in the slides on reduce would be waterless robotic solar cleaning systems, anti-stick coatings, high pressure jet cleanings, air to water, which is a very latest technology that we have explored, and the waterless urinals, water bags, and sensor-based taps. In the reuse, we have established cleaning wash water reuse schemes for all our products, which we again reuse them into our product groups, and water reuse in the utilities. Looking at the recycle aspect, where we'll be discussing about the treated water reuse for different applications in the plant. Reduce. So let's first talk about waterless robotic solar cleaning. So earlier we used to have solar panels cleaning using water only. So recently we came across this technology where solar panels can be cleaned without using water. So it's a completely automated solution using nylon bristled brushes. It's a programmed cleaner. It's a GSM based central gateway for remote communication. The impact that we have achieved out of this project was it gives water saving of around 111 kiloliters per megawatt per annum. Moving on to next initiative, the anti-stick coatings. So if we look at the paint production process, it has emulsion as a raw material. Paint in itself has stickiness property, because of which it sticks to the surface of the production vessels and the transfer lines. So the fluoropolymer are non-sticky and good abrasion resistant coatings. Teflon coating, which we applied on strainers, filters, and packing tubs. So the strainers, we have strainers in all the transfer lines to stop any bigger particles in moving up to next stage of paint production. Impact that we could see out of this initiative was 80% reduction in cleaning water requirement per annum. So through the use of these two picks, we can see cleaning after 9 months of coating. So the paint sticks to the surface, but if the surface is coated with Teflon coating, even with a gentle flush of water, it completely washes out. Moving on to next initiative, which is the concept of using high pressure jet cleaning. So we have used this concept in various applications. To start with reactor cleaning, basic concept is to increase the pressure and reduce the consumption of water used for cleaning. If I'll first talk about the emulsion processing. So in the emulsion processing, emulsion skin gets dried out once it comes in the contact of air. So during emulsion process, and this skin deposits on the reactor surface. So earlier we used to have a practice of solvent or caustic boiling, which used to generate a industrial effluent. So now this is replaced with high pressure jet cleaning system. The pressure of the Uraka system that we have established is 1000 kilogram per centimeter square. It has a huge impact in terms of freshwater consumption, reduction of freshwater consumption by 700 kL per annum. In the paint processing vessels cleaning, again, so in all the applications, we have used different pumps or the different jet guns. All are on the same concept of high pressure jet cleaning. During paint processing, paint again sticks on the surface of vessels or in the packing areas. So the pressure that we use in processing vessels is 150 kilogram per centimeter square. In the packing fillers cleaning, we use jet guns with a pressure of 500 bar, and the impact is 240 kiloliters per annum. Similarly, the same concept is applied on strainers and contaminated barrels cleaning. Through this high pressure jet cleaning, the water saving that we could achieve was over 1500 KL per annum. Moving on to next, which we recently explored, air to water. So in the picture that we see, this technology works, this is a dehumidification technology. Basically, the atmospheric air is driven in through blowers, and gets condensed. Now this condensed air is converted into drinking water through 7-stage filtration process. We have installed one of the machine in our plant and also use this for community service under corporate social responsibility. And the last aspect is in reduction is the domestic consumption, where we have taken several steps to reduce the domestic consumption in washrooms, where we have had all the waterless urinals. Urinal screens, which are made of EVA polymer, are used. It provides controlled and consistent fragrance. In the complete plant premises, sensor-based taps with aerators are installed to reduce water wastage while using taps. Water bags are being put in flush cisterns. So basically to reduce the water being used in every flush. The overall impact that we could see under domestic consumption was over 800 KL per annum. So all these measures we did to reduce our overall water consumption. Now we're moving on to reuse and recycle initiatives. Under reuse, so we have raw material in process and FG contaminated water that is getting generated out of processing vessels in the transfer lines. Now this contaminated water, so we have a complete infrastructure where we store this contaminated water and then use it again in the same product groups. So we have different product groups being allocated to different wash waters where we are using all this water. And this is completely in the auto mode. Whenever next this product groups comes, the wash water gets reused into the system. The overall impact of this initiative is whooping 3,500 KL per annum freshwater saving. Looking at the reuse that we do in the utilities, 100% RO reject is reused in domestic or cooling tower makeup. Also, the boiler condensate is 100% reused and recovered. So utilities also, we have taken several steps in reducing its water consumption. Now the other measures that we did to reduce water consumption are the native plantation. So in Roth plant, we have over 50 acres of green area where we have only native plantation, which reduces the water demand of the plants. Also maximizing ETP treated water for reuse and different purposes within the plant premises. We have started with the reuse of surfactant wash water. So surfactant comes out in one of the processes where we use this wash water for barrel decontamination. In barrels, we receive our raw materials for powdered and liquid raw materials. Now, the water conservation measures, the rainwater reuse within the plant premises. So we have a stormwater reservoir of 7,200 kiloliters and rooftop reservoir of 1,120 kiloliters. The complete rainwater gets stored in it, collected through various drain lines and then stored in these reservoirs. Now from this reservoir, it goes to a treatment facility of where ACF, DMF and chlorine dosing is present. Then it is used in the process water tanks, cooling tower makeup and gardening water tank. So the complete rainwater gets utilized in the system. So all this till now what I have discussed is the initiatives that we took inside the plant premises to reduce our water consumption and to maximize the reuse. Now we also have under the corporate social responsibility, we work in water conservation measures. The pictures that we are seeing, so we have had 297 rainwater harvesting structures built in Roth region in and around the plant. Then the first pictures that we are seeing is deweeding and desilting of ponds in the nearby areas. So once the weeds grow in the ponds, it becomes it's of no use to the community. So what we do is we deweed the complete pond and then desilt it to increase the capacity of pond, which makes it usable for the communities living nearby in the area. Also, the latest project that we worked with the farmers is on the canal lining work. So in around Roth region, people get water from the main canal. Now this water from the main canal comes to the fields via small channels or the canals that being built in the soil, where they were realizing a lot of conveyance loss in the water. So what we did is we made all these channels into a pakka channels to reduce this transmission losses that they were facing. So all these initiatives were taken with the communities around the plant. It lead to increase in groundwater table, increase in capacity of village ponds, and addressing the unfulfilled need of water for irrigation that the villagers were facing. With this, I'm coming to the end of the presentation. All these initiatives that I have discussed, so basically every year we take some sustainability goals that we try to achieve. We try to reduce our environmental impact and increase the reduce or increase the reuse of water. Also, we work with the communities. Thank you. To you, Rita.
Thank you, Arpit. Very interesting presentation again. So being used as for reuse within the business premises and not just as a CSR initiative. So that's also a very interesting aspect that is coming out from this presentation. So thank you. And
Rita, 1 minute. These are the initiatives which is we have planned under the Catch-Rain campaign. Actually,
I think we've had very interesting insights from 2 different corporates.
Okay, just one second. Okay, this is the actually the examples shown by Arpit is what we actually planned in the Catch-Rain campaign. We wanted to increase the storage capacity of the tanks of this area. Also wanted to have the encroachments of the tanks to channels to be cleared up, and all the weeds which are and the debris and all which is being put in the tanks to be, so that the volume or the capacity of the tanks are increased. What you have done is exactly in the lines with what we are planning. My request is that you also should try to motivate the people around your factory, not only just your immediate vicinity, but around your area, so that the water is got. One clarification since on the Catch-Rain, when we say okay, where it falls, see, it's just a slogan trying to motivate people to get it. So we are saying that our primary focus is on getting the water inside the compounds collected. Not that we should say, we are not saying that every water should be impounded there itself. That the compound, the water which is falling in your compound, the small premises of the areas and housing colonies, if that can be restored, then the water which is flowing to the roads and creating urban flooding can be controlled. So we are not telling that the water should not flow to the rivers and the flow should be damaged. So all the water which is flowing the other areas, in the forests, in open areas, all can flow and be part of the eco flow which we have mentioned. So I just wanted to clarify that it's not that everything should be imported at that place itself. It's a slogan. When we put it up with the slogan, it has to be something catchy.
That's important. When you give the slogan, then how people take, that's where you don't have the control. So I think it's important to also make people understand, and through the programs, because we have seen in the case of watershed management program also, it was done unabated, and many instances are there where the water is coming into the very big ponds, the tanks, and in various states like Karnataka, they started becoming dry because of the overdoing of the management program. So I think that those are the things I'm just trying to say, that we have to be very careful that when we are making the implementation through the policies, then some scientific analysis has to be done to put the trade-offs. And that trade-off is not a business of people who are the common people. It has to be as part of the policy.
Rita, please.
Yeah, no, thank you, Professor Gosain and Mr. Kumar. I think those are very important points to put forth here. And and that a proper scientific analysis is needed as part of the policy framework itself. So thank you for pointing that out. We have a set of questions that have come to us online, and if I may just take the liberty of reading out the questions on behalf of those who have asked. Mr. Atul Pandey has asked a question whether the model that you
Your voice
spoke about, Professor Gosain, is this applicable for audible now?
No, I missed the previous part. Can you repeat?
Yes. So we have a question from Mr. Atul Pandey. He says he's asking whether this model that you were speaking about, is it applicable for cross-boundary river basin or not? Example, Gandak, Bagmati, Kosi basin.
Yes. When we have done for all the river basins, basically when we are taking Ganga, we are not taking Ganga which is in India only. We are taking Ganga which is coming from Nepal, which is coming from China. When we are taking Brahmaputra, we are taking the total Brahmaputra. Because the river system cannot be segmented because of the transboundary boundaries. It has to be taken as a full system. So when we simulate, only question can be that some of the data might not be available with us, which is the localized data in terms of what structures are there, how much diversion is taking place, how much you are storing in the reservoirs. So those data might not become available, but we have taken the hydrology, the natural hydrology of all these basins while doing the simulation. So this is, the model can be used for a watershed. It can also be used for a basin. And that's what we have showcased. And that is what, when we are formulating the forecast, is on the basis of all this analysis, taking the terrain, taking the land use, taking the soil, and then also taking the weather conditions. What is the temperature? The temperature will decide how much evapotranspiration losses will be there from the land use, because you are growing crops. So it's a very sophisticated model which simulates all the natural processes taking place in your system.
Since this has been there for the last 2 years, 2017 onwards, you told it is there.
We started in 2017.
So how much?
Okay, thank you. The next question again.
How much have you cross-checked with your predicted models and the ground truthing done?
Yes, we have cross-checked the simulation, the validation part when we have done the simulation, having the known data of the past historical period. But as far as the cross-checking the system as we are making the forecast, that is not under our purview, because unless we have the tie-ups with the state governments and the Sand Water Commission, where we can get the data and then verify that how much we are giving and how much is actual observed, because there's a lag between that data. But it can be done. See, what I'm saying is that the system is ready to be deployed anywhere in any part of the country. We have ourselves done in 2 places. The Tapi was one. So Tapi, the Surat people had asked us to create the system, and they are still using those forecasts. And then the next one we did for the Orissa people, the Orissa Water Resources Department, and there also we deployed the system in their place, and they are using that system now.
Thank you. Dr. Gosain, there's another question related to your. Am I audible? You're on mute.
Sorry, I'm on mute. No, I was not able to hear you. Can you repeat the question, please?
I'll repeat it. By using your modeling approach, could you forecast the rise or fall of groundwater tables?
The present model doesn't. the present model has the capability of telling how much will be the recharge from the
water quality issues.
From the natural rainfall, as well as the irrigation if you are doing. So what will be the recharge? This model tells that. But if you want to know the absolute value of the water table, then you have to also deploy the groundwater model, as we did in the case of the Ganga. The Ganga basin, we had used both the hydrological models and the groundwater models. So in the present case, we are able to tell how much is the groundwater recharge, quantifying that, but we are not in a position to tell that what is the implication on the groundwater table per se in absolute terms, that where the groundwater table will come. For that, you need to have additional models. So that is what is the present status. But it can be done. It's not very difficult.
Right. Thank you. Thank you, Dr. Gosain. And there are a lot of questions for you actually. Dr. Raman Saravanane from Pondicherry Engineering College has asked, what preference and priorities, I'm sorry, I think this could be open to the other panelists also. What preference and priorities that does
You're frozen again.
Owners transform under sequenced material. Okay, I'll just repeat the question once again. Am I audible now?
Mm-hmm.
He's saying what preference and priorities industrial owner transforms under sequenced material flow and energy flow, keeping specified treatment alternatives under BAT as crucial if BPT fails to meet the requirement of specified output.
I think let the other industry people address this.
Okay, okay. Dr. Anand Rai or Mr. Arpit, would you, either of you, like to take the question? Yes.
Yeah, actually, yes. There is 2-3 questions which is almost similar of Dr. Saravanan. Actually, whatever BAT or BPT technologies are available globally, which is already proven technology, that we are replicating here. So first we demonstrate at one of the plant, and after successful of the implementation or good result, then it replicate to other plant. So this is the way we choose and execute the BAT in India, in Indian scenario.
Thank you. Thank you for answering that question. We have one question to Asian Paints from Mr. Narasimhan Venkateshan, who's asking what would be the financial savings to Asian Paints after introduction of the water saving technologies, keeping in mind the investments involved in the trade-off. So, Arpit, could you throw some light on that?
So there were financial savings in terms of effluent treatment, the savings that we could achieve in effluent treatment. But still, I would like to highlight that these projects were never implemented for financial savings. These were implemented to improve the sustainability performance. So yes, financial savings come as a byproduct of it, but the major priority for implementation of these savings, because if you go for the cost benefit analysis, only cost benefit analysis, then you might not be able to do those projects, because the high pressure jets that I mentioned, some of them were costing more than 1 CR. So you have to look at the whole approach, that how much sustainability performance improvement I'm getting out of these projects, not just the financial savings. Thank you.
Thank you, Arpit. We have another question to Professor Gosain. Are there any, Dr. D.S. Bish from the National Institute of Hydrology is asking this question. Are there any documentations that are that's available to refer for the modeling exercise that you have just spoken about, and how the modeling framework has been set up? Is there any documentation for reference available?
Yes, there is. We have put in a user file which gives the details on how a user can use it. So the link is there, and link I have also supplied in the presentation. So I think once you go to the link, you can get some limited user assistance. But basically, we have used the model, and the documentation is not in the form, because these kind of things don't have documentations of that kind. How the model is doing. The model is basically a public domain model which we have utilized. So I think in these online systems, you cannot give those kind of links are there. You can go to the site of SWAT and download the SWAT model. But we have given the user requirement, how user can effectively use this. That is incorporated in the portal.
Right. Thank you, Professor Gosain. And one last question that we can take up, because we're running out of time now, is from Mr. Amit Kumar Mittal. And maybe I should direct this to you, Mr. Ashok Kumar. He's saying that there may be a need to add one more R, which is review. Review of per capita requirement downwards to understand the value of water, review of putting price tag based on all India state level or district level cost worked out, rather than subsidizing to economize the use, review of water actually being supplied versus requirement. So this is like
Yes,
an observation, but if you'd like to read to this.
Yes, it's a very important point, because the biggest problem of water conservation efforts is that the water is not priced. The value of water is not known or appreciated by people, because if you look at the earlier systems, the states used to compete with each other to give free water to industries, to set the industries set up. Now the water pricing has come in some particular states like Gujarat and all. They really ensure that the treated water of the municipalities are used first, and then only the other water is used. The municipalities like Surat and all earn about more than 300 crores rupees from the sewage water, which is actually in many states, many municipalities do not have amount to run the municipality or pay the staff salaries, whereas municipal corporations like Surat and all, they generate so much of water from the treated wastewater. So water pricing is very important, and if you can actually put up the whole matrix of valuation of water and the price water and the pricing of water, probably things would work up. So what you said, the review is very important. If they pay price for it, they start reducing the usage of water, and they will definitely be more economical in the water usage. There are 7 models available. There are 7R model available also. There's a 4R, 3 Rs. So many Rs are available. So and these are all management terms which ultimately comes in, but definitely review is very, very important. That's why I said about the water audit. The National Water Mission is also helping in many industrial, not factories, but industrial sector as such, do the process re-engineering by doing the water audit and trying to suggest methods which they can incorporate in the system to reduce the water usage. Water audit is a part of it. The review is also part of it.
Thank you, Mr. Ashok Kumar, for your observation on this very important point, and the fact that water audit itself is very, very essential, because you can only manage what you measure. And so from that perspective, I think measurement is very, very important. The end of today's webinar. The time is over now, and we've had another very interesting session with new insights that have come up and a new experience sharing by the corporates. It's interesting to see what kind of initiatives are being taken in as part of the business process improvement, the industrial process improvement in various industries, and that some of these leading companies are making these conscious choices, not just from a point of in order to take their sustainability agenda forward. So that's a very interesting insight also that has emerged today. So thank you to all the distinguished speakers and as well as the participants. If there are any further questions, please do send it to us at watermission@ficci.com, and Fiki will channel the information and the questions to the National Water Mission. The National Water Mission is going to come up with a comprehensive set of FAQs after the webinar series, so that everybody's queries are addressed on the National Water Mission website under Catch the Rain campaign. So thank you very much, and we come to an end of these webinars. Will be held on.
So I request all the participants, please inform us the good practices which we are doing on these water conservation methods in the National Water Mission website, or I can give you a simple website to remember. We have created it is catchthe_rain.nwm@gmail.com. Just catch the rain, one word, .nwm, National Water Mission @gmail.com. I request all of you to share your best practices, because we are all now collecting the various efforts made by various institutions, industries, and organizations for conservation of water. I'd like to share this best practice to the other people. So please send your information and the good practices you do to catchthe_rain.nwm, National Water Mission, catchthe_rain.nwm@gmail.com. That's one part of it. And second is, I also like to inform you that water talks, which we are doing, National Water Mission, it's always done on the third Fridays of the month. 21st of August, we will have one water talk. So all of you can check up with our website and join the the water talk. Thank you. Thank you.
Thank you, Mr. Kumar. Mr. Kumar has already given one email address of the National Water Mission, Catch the Rain. You can send it to either of these email addresses, your queries, and all the will be there. The next one in this series, which is on the 29th of June, is on water use efficiency in agriculture. So that's our next webinar. You can join that. So please send us your nominations at the early